a validator info, it sounds like it's something appropriate for regulation or something. It's kind of like an add-on to the validation, right?
So it's mostly intended for the person who's writing the validator script to make sure that the person who spends it does the right thing with it. So I didn't go into the details, but let me give you a more concrete example that would maybe make it clearer.
I mean, when you said the right thing, it kind of you mentioned.
Yeah. So let me give you an example of the right thing.
Yeah.
So one thing you might want to do is you might want to implement something a bit like a little state machine with this. So you'd say, like, maybe it just keeps track of how many times someone has tried to use it or something. So the validator script would remain the same, and in the data script, you keep like just the counter of how many times someone has used this. But in order to make sure someone uses this correctly, they have to spend the old output and produce a new output that has the same validator, and they've updated the state appropriately. Now, we need to make sure that the old validator has to check that they do that. Otherwise, who knows what they might do? They might do anything. They might take all the money. That'd be bad. You might want the money to stay locked up until something happens. So sometimes where you have these chains of transactions where things have to keep going, but you don't want everything to be serialized through a trusted party. You don't want to be the only person who's allowed to update this because, that's tedious and slow and expensive for you and not distributed. So instead you want to say, sure, anybody can update the state of this, but we're going to make sure that they do it the right way. And so that's one of the things that we get the ability to do is we can actually look at what the next transaction is doing and make sure it's the right thing.
So it's kind of something you could see it as a single transaction, but made up of a finite series of transactions.
Yes and no. I mean, there's interactions going on with people, right? Like it's not one transaction.
It's complex. Okay.
But another example of that is if you think back to the escrow contract, and if you did that on Bitcoin with multi-sig, Carol and Bob could split the money between them, for example. So multi-sig, all it says is these two people have control of that money, and they could do whatever they want. What we can do is make sure that when they do that, when they both free it, it goes back to Bob, for example. So
That's a much better example. Thank you.
And that was, Pablo and I, when we were thinking about Marlowe, that was one of the things we thought, we've got to be able to do that. We want that control. And that was I think that's...
I gave the overly generic example, which is that this is an example of implementing sort of state machine type stuff, which turns out to be really useful.
But we're coming in, it's different ends of the same thing. But yeah.
Yeah, I have a quick question over here. Right over here with my hand up in the middle.
Hey. Oh, there.
Right. Oh,
several people with their hands up, sorry.
Well, several microphones, that's the trouble.
Hey, so I understand how this applies to crowdfunding, but I also saw you guys have demos on games, vesting, and messages. Can you just describe how it applies to vesting?
Sure. So I won't go through, I'll just explain. So what we implement in this example is a scheme where there's some money locked up. So we say, here's some money for you, but you can only have it in chunks, and the chunks become available beyond a certain time. So after a certain time. So then the validator is exceptionally simple. It just says, you're trying to take the money. Is it past 2 o'clock? Fine, you can have this much money. Is it past 3 o'clock? You can have this much money. So it's a very simple vesting. Yeah, I mean, anything you can talk about on the Cardano chain.
Well, there's the issue about fungibility, I guess.
Sure, right. So you wouldn't do it with ADA. If you were doing something like that, if you're tracking assets, you want a non-fungible token or something that actually represents the thing. So I guess shares are probably not fungible.
Yeah, I know, yes.
Not sure.
All right, so do I understand correctly that a contract is an address, and then is it possible to upgrade a contract?
So the word contract is somewhat overloaded.
Sure.
So you can, if you want to lock some money using a script, you effectively pay to the address of that script. And if you're doing the sort of state passing thing that I was describing, then that address is a lot like the address of a contract in the Ethereum world. As for upgrading it, if you upgrade it, it's going to have a different hash. It's going to have a different address. So no, unless you add functionality to do that. It's there's no special backdoors built in to help you avoid accidentally putting all your money in a runaway machine that does something stupid. That is still something that you, the programmer, not need to make mistakes by using Marlowe or something that only lets you do sensible things. I think we hope in future to explore more techniques for using formal methods or similar to try and help people not make that kind of mistake. The other thing you could do is actually build functionality into your contract to allow it to be changed or allow some of its parameters to be changed. But of course, you can make mistakes doing that, and then you just accidentally let someone else change all the parameters or something bad. So it's yeah.
But also building libraries, I suspect. So we'll be building and encouraging people to reuse those.
What is Marlowe but a very fancy library?
Well, indeed. Yeah, exactly. Yeah.
Hi, it's one for Simon. What issues have you had modeling exotics with Marlowe?
None, because we haven't done it yet.
Okay, that sounds fair enough.
So that's.
Thank you. Hi, just a question with regards to, you mentioned or used an analogy with regards to the mafia and them using the technology for bad things. Where is KYC dealt? Like, on how does it work? Is it in Marlowe or is it in the validator script?
I do not believe we are going to solve KYC for you, I'm afraid. So you could build something that made it easier to do KYC on top of this. You know, you could have systems which would only accept transactions to like addresses that were known to be trusted or something, and you could have someone else update the ledger of trusted people. You could build that sort of system on top of this. This is the plumbing for building these systems. If you want to do something where only certain people are allowed to do some things, you have to do that on top of.
Sorry, maybe you missed my question. You said earlier that the validator script can tell if someone's doing bad things.
You have to be able to tell me how. You have to be able to write the program that tells whether it's bad. There is no magic bad thing detector, right?
Understood.
Like if you can tell me how to see whether the thing is bad, sure, you can detect whether it's bad and abort the transaction. But if you don't have the information to know whether it's bad, just paying to some public key who knows that it's owned by the mafia, that's not a problem that we're solving for you.
Okay, thank you.
Okay. We have one more question at the front, please.
Why is it called Plutus?
Plutus is the Greek
Roman,
god. No, I think it's actually Greek.
Is
It
it
sounds
Greek?
Latinate,
It
but I
sounds
believe it's in
Latin.
fact Greek.
Okay.
I remember this because it was not Latin. I also
Okay,
thought that.
fine.
I
Sorry.
believe is the Greek god of wealth.